Here in 4.2a, we're going to be taking a look at two different types of functions, linear and quadratic functions, in a little bit more detail. Taking a look here at our objectives, linear functions and their graphs. This hopefully is a good review from what we've done, what you've done in either intermediate or whether you came out of Algebra 2 or something like that. Quadratic functions and their graphs, again, we'll look at an introduction to those, and we'll continue working with these types of functions throughout Chapter 4, really the rest of college algebra. Let's first take a look at linear functions, and these are really the introduction of functions, the first type of functions that we're looking at. A linear function is any function that can be written in this form. And if you remember, f of x is the same thing as y. So if you look at that form, doesn't that look familiar to you? Or hopefully it does. That's your slope-intercept form. And so y equals mx plus b. Anytime we can write something in slope-intercept form, it's going to be considered linear. This is also called the first degree function. Now the reason it's called first degree is because whenever we have variables involved, in this case the y and the x are my variables. M is our slope, and then b is your y-intercept, if you remember. And the y-intercept is a point, and so when we call it, it's going to be 0 comma something, because the y-intercept always has, the x value is always 0, so some review there. But it's called the first degree function because the degrees of the variables are 1. Okay, and so when we get to a quadratic, we'll talk about what it's called. It's going to be called a second degree function instead of a first degree. So linear functions where we're going to start. You need to make sure you're able to find the slope and the y-intercept of linear equations. In other words, how do I do this? It's pretty easy. Put in slope-intercept form. If you can put it in slope-intercept form, then what you can do is identify what the slope is and what the y-intercept are. So slope-intercept form, just again a review, is y equals mx plus b. Whatever the coefficient is in front of the x, once y is isolated. So how do I put it in slope-intercept form? It's actually pretty simple. Isolate the y. Okay? Once the y is isolated, then whatever the coefficient of the x is going to be the slope, and then whatever the constant is going to be your y-intercept. Okay? Now, taking a look at a graph of a linear function, obviously the word linear, you see the word line falls inside. All of the graphs are going to be lines here. So if you know it's a first degree function or first degree polynomial, you know it's going to be a line. We just need to know where the y-intercept and what the slope are so that we can graph this thing. Now, something besides the slope and y-intercept that you can also utilize is, remember, a t-chart or a table of values. And so you can utilize those by simply plugging whatever you want in for x. A lot of times we do like a negative, a positive, and 0, and see what we get. So sometimes you'll get fractions over here if you do this, but this is always this is a nice, safe thing to do. So if you're unsure if you're doing it right with using slope-intercept form, definitely you can utilize a t-chart to assist you in graphing. Now we're going to get a problem like this one. Now first off, f of x is the same thing as y. F of x, same thing as y. And so we can rewrite this as y if you want to. You don't have to. You can leave it f of x, but I want to show you the slope-intercept form. Notice we have an STD, a single-term denominator. How do we get rid of this STD? Well, we stack and we simplify. So we stack, and then we end up simplifying this expression. And so we end up getting y equals 2 plus 3x. Now, that's not really in slope-intercept form, even though we could figure it out. If I use commutative property of addition and change the order of those two, now I can identify what my slope is and what my y-intercept is simply by memorizing y equals mx plus b. So y equals mx plus b. If you notice, our m would be 3. It's the coefficient in front of x. Now, 3 is, as a fraction, 3 over 1. So even though our slope is 3, another way of looking at that is 3 over 1, which means we rise 3 and we run 1. It's the change in y's over the change in x's. And so we have the steepness of a line of 3. And so we're going to be going up 3 and over 1 depending on where we start. Well, where we're going to start is at the y-intercept. And if you take a look here, what is our y-intercept? In this case, it's a positive 2. Now your y-int is an actual and ordered pair. And so it's going to be at negative 2, but your x value is always 0. Now if you think about it, here's your y-axis. So where a graph crosses that axis, the x value is always going to be 0 right there. And so no matter where it crosses, up here, here, or in our case at negative 2, our x value is always going to be 0. So there's our y-intercept. From the y-intercept, execute your slope, a slope of 3. Now, it's a rise of 3 and a run of 1. Now, it's a positive 3 over a positive 1. Positives are directions, negatives are directions. So when a positive 3 means up, that's a rise up 3 and a run to the right 1. Positive means to the right or up. Negative means down or to the left. And so what we have here is a positive 3. So we're going to go ahead and execute that going 1 1, 2, 3. And then we go over to the right 1. And this should make sense if you recall from our slopes back in intermediate or in Algebra 2 or whatever class you came from. Positive slope should be uphill left to right. And so that's what we have. And at that point, you can keep doing it. You can actually go down 1, 2, 3 and to the left 1. That'd be like -3 over -1, 1, 2, 3 over 1, and so on. And we can keep that pattern forever as long as we get that line. And there's our graph of that linear function. Identifying the y-intercept and identifying the slope is also going to be very important to you. Okay, moving on. Taking a look at one like this. Now, this is a little different. G of x equals 3. Now, what's g of x the same as? You're right, y. G of x is the same thing as y. So y equals 3 is what we have. Now, notice what we have. Y is 3. That's how another way I can write it. So no matter what x is, y is 3. Okay, y can't be anything other than 3 because it says y is 3. And so if x was 0, y is 3. If x was 1, y is 3. If x was -1, y is 3. And if you plot these points, you can really see what the graph's going to look like. -1, 3. 0, 3. 1, 3. And notice what we have are these 3 dots. And so go, okay, I need to connect the dots. Now, a little review here. How do I know I connect the dots? You connect the dots anytime you have an equation. If it's just a set of ordered pairs, like this is just a sample. That's all a t-chart is a sample of ordered pairs. It doesn't give you the whole picture. The whole picture is actually this line right there, which is a horizontal line. This is just a sampling of that line. We have 3 points on that sample. Okay? But anytime it has an equal sign, that means you connect the dots. It's always going to be connected. Now, you can also just memorize when y is by itself, it's going to be horizontal. Now, a good way to remember this is if you remember horizontal or horizon, because that's the horizon, it looks like this. Okay? And so horizontal is going to be that way. And so if you can sort of squish them together, it sounds a little weird, but this is a good way to remember it. It's horizon. Okay? And so when y is by itself, you're talking about a horizontal line. When y is by itself, you're talking about a horizontal line. In other words, the x isn't there. Now, we only have, it's still a degree of 1 because we have a variable. It's just y. Now think about it. Let's do it in reverse. Now it won't be a function, but if x was by itself, then we'd have a vertical line. It's not going to be a function because it doesn't pass the vertical line test. And again, we referred back to 4.1 if you want to go back and look at the vertical line test again. Let's look at a couple problems here. If you look at the very top one, it says find the slope and the y-intercept entered as an ordered pair. So keep in mind your y-intercept needs to be entered as an ordered pair, which we already know what the x value is. It's 0. Anytime you want to find the y-intercept, just plug in 0 for y, or excuse me, for x and solve for y. And that allows you to find the y-intercept. Or you can put it in slope-intercept form. And that's what we're going to do here so we can find the slope and the y-intercept at the same time. So we look at this problem. The function's a little bit funky. Okay, we got 3x minus this quantity 7 plus 9x over 2. You have some choices here. You have an STD, so you could stack the 2. And make sure to distribute your negatives. You have some options there. You can't multiply everything by 2 because we want to leave this as just y. You could get common denominators, and that's how I'm going to approach this. Is I'm going to go ahead and make that a 2, and that makes this a 6. So I end up getting 6x, and I can squish them together. And I'm going to keep the bubble. Now, hopefully you can recognize why I'm keeping the bubble. Once I get here and I have 6 minus the bubble, and I can squish these together and leave the 2 on the bottom. That's how we add or subtract fractions. Common denominator, squish them together. Now what you can see is the reason I left that bubble there is make sure to distribute that negative. Man, that's a huge thing for students to remember to do, is to distribute the negative when possible. And I think this is a great representation of that. 6x minus 7 minus 9x. All over 2. And now what we can do is combine our x's on top. We end up getting -3x minus 7 over 2. Now that still isn't quite in slope-intercept form, but I'm really close. If I put the y out here, this is going to lead us to y equals what? Well, it's an STD, so stack and simplify. It's how we get rid of STDs in math. And so we go ahead and we stack this, and we get -3 over 2x, and then we go ahead and we get -7 over 2. So what you'll notice is that's in slope-intercept form. Y equals mx plus b. And so you can see it, y equals mx plus b. Our m is going to be this -3 over 2. There's our slope. And so we would type that in. And then our y-intercept, if you look over here, is going to be negative. Now associate the sign here. So if it's a negative, it's going to be, if it's a minus, it's going to be a negative. -7/2 is going to be our y-intercept. Now, we still need to graph this thing, just to show you that we know what the graph is. The y-intercept is negative 3.5, okay? So negative 7 over 2 is negative 3.5. So I'm going to go to negative 3.5 and I put a dot. From that dot, I'm going to execute a negative 3 over 2 slope. Now, negative slopes mean downhill, left to right. So when I go up 3, so if you look at it like this, you can go up 3, but I'm going to go to the left 2. That's still negative 3 halves. So I'm going to go 1. Okay, let's put it in a different color here so you can see it. Okay, so I'm going to go 1, 2, 3, and then to the left 2. 1, 2. And there we go. 1, 2, 3, 1, 2. Put a dot. And if you notice, our dots line up really well. We draw that line, and there you go. There's the graph. We have the information for the slope and the y-intercept, and there's your answer. Okay, moving on. Let's take a look at the one at the top. Probably a little bit easier to at least manipulate. We're not going to graph on this one. We're just going to find the slope and the y-intercept. But notice again, what's popping out there? That distribution of a negative. Okay, we got to be very careful to distribute that negative. So you end up getting 6x minus 15 plus 18, because double negatives make a positive, and then minus 3x. Really watch and make sure that you're distributing negatives properly. Really messes things up if you don't. We're not moving anything. All this is on the same side, so I'm not going to add 3x. That'd be like there's an equal sign here. What I do have is 6x minus 3x, which is 3x. Negative 15 plus 18 is a positive 3, and there we go. What's p of x the same as? Same as y. So there's our slope-intercept form, y equals mx plus b. What's our m? Slope is 3, which is again is like 3 over 1. And then what's our y-intercept? They want it in ordered pair form. Our x is always 0, and our y in this case would be 3. And then we could graph it if we needed to. Taking a look at the bottom one here is a little bit different than slope-intercept form. We're actually using the second formula back in early algebraic skills that you've learned. And that is writing or finding an equation. And there's two things you need to write a linear equation. So this is what you want to remember. What are the two things you need to write a linear equation? You need a point and you need a slope. That's it. Now, why would I need a point and a slope? Now, a point is an ordered pair with an x and a y. Okay, we'll call it x sub 1, y sub 1. The slope we'll call n. Okay, obviously because slope starts with the letter n. Okay, and so we go ahead and we have a point and a slope that we need. We're going to use the point-slope formula. Now, this is the one that usually we tend to forget. Okay, so we'll bring it back up. Point-slope looks like this. Y minus y sub 1 equals m times x minus x sub 1. And so what you have is a point. That's the x sub 1 and y sub 1. And you got your slope. That's why they call it the point-slope formula. It helps you write equations. You can use slope-intercept form and do some other ways with it, but I think the point-slope's the best way. That's what it's designed for, so let's use it. It comes from the slope formula, the change in y's over the change in x's. And you can see that if I took this bubble and moved it underneath these y's, that's where it comes from. And so now we can go ahead and we can say, look, instead of knowing 2 points and finding slope, I know 1 point and I know the slope. And so in a problem like this, I know a point. Now, it's hard to see the point here, but what we have is whatever's in the bubble is our x value, and what it produces is the y value. This functional notation simply means the ordered pair negative 6, negative 5. And then obviously our slope is given. And so this is our x sub 1, y sub 1, and this is our m. And so now we can go ahead and really just plug and chug. And it goes like this. Y minus y sub 1 equals my m, negative 5/4, times x minus x sub 1. So we got some arithmetic to do left, but we're in really good shape here. And so what we have is double negatives, which makes a positive. And then over here I have a double negative, which makes positive. And then hopefully you can recognize. Now, technically we're done. I mean, that's the equation. So if they allow me to write it in like that, I'm going to do that. And so unless it says put it in slope-intercept form, that right there is a linear equation. We're done. Okay? Now, if they want you to put it in slope-intercept form, you only have to do 2 things. Distribute, move that constant. Distribute, move the constant. Distribute, move the constant. So we go ahead and distribute the negative 5/4. And so when I distribute the negative 5/4 here, the 6 and the 4 are going to take a 2 out. So I end up getting negative 15 over 2. That's what we'd end up getting. And now I can go ahead and subtract 5. Now 5 is the same thing as 10 over 2, so that's why I'm putting 10 over 2, so I can get common denominators. So I end up getting y equals negative 5/4 x, and then on this one I get negative 25 over 2. And there we go. Their slope-intercept form. It's the same equation as this one, just in a different form. Remember, there's standard form, there's slope-intercept form, there's point-slope form, there's different forms for quadratics as well. Speaking of quadratics, that's what we're jumping into at this point. Let's go ahead and take a look at these. Now, what is a quadratic function compared to a linear? Remember, a linear is called a first-degree polynomial or first-degree function. A quadratic is a second-degree. Okay, so if the linear one's called first degree because the exponents of the variables are 1s, wouldn't that sort of lead you to believe that quadratics are called second degree polynomials because it has a degree of 2? Because you would be right. That's called the quadratic term. The ax squared is called the quadratic term. This is called the linear term right here in the middle. Why would they call it the linear term? Because it has a degree of 1. And this is called the constant here at the very end. And so what we have is a quadratic function. We name it according to its largest degree. Okay, it's sort of like its ranking. The graph of any quadratic is a U or an N-shaped. We call that a parabola. And a parabola, we'll take a look at what they look like right here once we go through sort of a T-chart. Again, we'll learn some other methods of graphing quadratics, but right now, let's just use a T-chart. And so we have a T-chart set up. There's our x, f of x, same thing as y. So I have an x, y T-chart here. And I'm going to plug in these 4 points. We've got to plug in a few more with quadratics until we get the hang of them than we do with linear. If I plug in -3, now be very careful. We've talked about this, but if you plug in -3, make sure that you don't plug this into your calculator. Okay, so if I replace the x right here with -3, don't plug that, you're going to get -9. And that's not the case. What we're looking for is, remember, whatever is in here. So if I want to find what -3 is, the bubble replaces the x, the bubble. Okay, so I have to square -3, which ends up being simply 9 is what we get there. And so -3 squared is 9. -1 squared is 1, 0 squared is 0, and 2 squared is 4. So if we plot these points, you can really sort of see the parabola shape starting to establish. And so there's some points there, and then 2, 4. And then what we have is -3, 9, which is really off the screen kind of thing. We could plug in some other values like 1. What's 1 squared? 1. What's -2 squared? 4. And so on. And so you can see some symmetry here. You see how these sort of fold on each other? And we'll talk about that a little bit. But I think we're in pretty good shape to graph this parabola. And so it would look roughly something like that. And so this would be a U-shaped parabola. But definitely a T-chart will allow you to graph such an example of a quadratic. Now, let's talk a little bit more about the components of a quadratic. One of the major components is the vertex. We're going to use a lot of vertex in this section and in the next. But the vertex is where the parabola changes directions. Sometimes we call it to the very bottom of the bottom, okay, down here. Or the top of the top, okay, way up there. So it's extremes. Okay, it's extreme bottom or the extreme top, depending on its concavity, the parabola's concavity. And so the vertex has a lot of meaning to us at that point because it tells us a lot about that function. It's the very bottom, and you can start seeing symmetry to the right and left of the vertex. So that vertex is a really important point, and we're going to be finding it and utilizing it quite a bit. But definitely it's where the parabola changes directions. So if I said, where's this parabola going downhill? In other words, it's going downhill here from -infinity all the way to, in this case it looks like 0, but to the vertex. And then from the vertex 0 on to infinity, it's increasing. And then we would have the reverse of that over on a concave that's negative. It would look something like this. Okay? Now, let's talk a little bit about the vertex more, but also the axis of symmetry. Now, an axis, we're used to the y-axis, we're used to the x-axis. An axis of symmetry. Symmetry simply means it's like a fold line. That's a good way of looking at an axis of symmetry, as a fold line. You talk about models who have very symmetrical features in their face. Means, I know it's going to sound morbid, but if you could take their face and fold it over on top of itself, it would line up really well. So most of us, if we take our glasses off and lay it down, they wobble on the desk because our ears are a little off and things like that. And so there's not symmetry there. So symmetry means we could fold this over and hopefully it falls right on top of itself kind of thing. Now, the axis of symmetry is an equation. It's a line. This is a fold line, okay? So what we have is, notice it's a vertical line, and a vertical line is x equals. Okay, so when we talk about an axis of symmetry, we're talking about an equation because it's a line. Now, notice it goes through the vertex. So whatever the x value is of the vertex, so like in this case, let's say it's 5, then the axis of symmetry would be 5. If the vertex was way over here and be like -3, the axis of symmetry would be x equals -3. So whatever the x value is of the vertex, that's the same value as the axis of symmetry. Now, what is the x-axis of the vertex? Well, we'll introduce that right now. The x-axis of the vertex, the x value, the x value of the vertex is the opposite of b over 2a. That would be the x value. So what does the axis of symmetry equal? The opposite of b over 2a. Now remember, the vertex is not a line. The vertex is a point. It's an ordered pair. And so what we're talking about here is we're talking about the opposite of b over 2a is the first coordinate of that ordered pair. And so that is the opposite of b over 2a. Now where does the a and the b come from? Let's talk about that. If you remember in standard form for a quadratic, okay, so we got to go all the way back and talk about this part right here. This is your standard form for a quadratic equation. And so we have an a, which is the quadratic terms coefficient. The b is the linear terms coefficient. And the c is obviously your constant. And so I need to be able to identify the a, the b, and the c properly. We did this when we solved quadratics, when we did quadratic formula and completing the square. We needed to know, and even factor, we needed to know what the a, the b, and the c were. So here we need to do the same thing. It's the opposite of b over 2a. You'll need to memorize that. That's going to come into play quite a bit. Now we'll talk about how to find the y value here in just a moment. But right now let's just stick with the x value. That's pretty important, finding that x value, because it also allows us to find the axis of symmetry. But the vertex is very important for us. Okay, moving on. Let's take a look at a quadratic and look at its graph. And we could find its vertex possibly to help us out, but we'd have to expand this. This is not in standard form. So we're still sort of at a t-chart dealing with, but I want to show you where the vertex is as well. So let's do the t-chart first. I'm going to go ahead and plug in 0. I get -3 squared, which is 9. I plug in 2, okay, and I'll go ahead and show you this. I plug in 2, 2 minus 3, which is -1, and -1 squared, which is 1. Okay, so that's what we get when we plug in 2. If I plugged in 3, I get 3 minus 3, and 3 minus 3 is 0, and then it's 0 squared. 0 to any power would be, other than 0 itself, would be 0. And then what we have is we have 5 minus 3, which is 2, and 2 squared ends up being 4. And so, sorry to go quick, but got through it. Okay, now we can plot the points, and we got 0, 9. Again, that's a little bit off the graph here. 2, 1, 3, 0. And look at 5, 5, 4. See how we went up? We're going down. And at some point, we went back up. Let's try 4. Let's plug in 4. We end up getting 1. Okay, so, ooh, there it is. See how I must have came down here and then went back up. And where we changed direction should be the vertex. So right now it looks like 3 zeros are vertex. Let's go ahead and expand this real quick and go ahead and find out what our vertex is using the opposite of b. Well, the a is 1, the b is -6, and the c is 9. What's the opposite of -6? 6. So what we're doing is the opposite of b over 2a. That's what we're doing here. So what's the opposite of -6? 6. What's 2 times 1? Well, that's 2. So I get 6 over 2, which is 3. That is my x value of the vertex. That's what we said it was. We can plug it simply back in to find the y value. That's one way of doing it. And we got 3, 0 is our vertex. Okay? Now, what's our axis of symmetry? And I'll abbreviate that as AOS. The axis of symmetry is going to be x equals because it's a line. And it's always the same x value as the vertex. So it's going to be 3. Now I can go ahead and graph this thing, and then I can fold this over. Now, here's a little side note here. Axis of symmetry, what is it used for? Here's our axis of symmetry right there. What's it used for? It's a fold line. So if this dot I knew, I can fold it over, and guess where it lands? Right there. And this one, look how far away it is from the axis of symmetry, 2 units. So if I folded it over, it'd be 2 units away. So as long as I know one point, I can find 2. As long as I knew the axis of symmetry. It's a fold line. It's great. So this one would fold over here somewhere, like right in there. And it allows me to find some points without necessarily having to use a t-chart. And so there's our parabola, using some of the components, but also using a t-chart as well. Okay? Now, let's talk about another form. We've talked about the standard form for a quadratic. And now we need to take a look at what we call the vertex form of a quadratic. This right here is called the vertex form of a quadratic. G of x, which is y, is equal to a, that's our quadratic terms coefficient, okay, so sitting in front this time, x minus h squared plus k. Now, this right here, the h and the k are very important to us, okay? The h and the k represents our vertex, the hk. Now, let's talk a little bit about the hk. The h is the opposite of h here, minus h. So this is what students have trouble with. When I give them something like this, x plus 3 squared minus 4, and I say, well, tell me what the vertex is. They need to find the h, they need to find the k. When you look, it looks like your h is a 3. I mean, when you look there, it's like it's 3. It's not 3. It's the opposite of what you see. Okay? So it's what they call being counterintuitive. Okay? So the h is counterintuitive. Now, what does counterintuitive mean? Well, really, an easy way of saying that is the opposite of what you think it should be. It looks like it should be 3, so I bet you it's negative 3. So h is negative 3, because it's the opposite of what you see. Let's say I gave you one x minus 3 squared plus 4. Okay, a little different on this one. It looks like it should be negative 3, but actually it's counterintuitive, so that means that your h is 3 for this problem right here. Now, if we go back and say what the k is, now the k is not counterintuitive. The k is exactly what you see. And that's how you do it in math. If you have a negative in front of a variable, that means the opposite of what you see. This one just means exactly what you see. And so what do we see? I see a negative 4. And so what is our vertex? Negative 3, negative 4. I didn't have to do anything. All I had to know was the vertex form in order to find the vertex. Over here, what's the vertex? Well, we already said the h is 3, and my k would be 4. You need to be able to identify the vertex from a quadratic and vertex form. You need to be able to identify how many x-intercepts there are and where they occur. Now, when we talk x-intercepts, I'm going to erase some of this. Actually, I'll just go to the top here. There's some room. When we talk x-intercepts, what we're talking about here are the roots, or where it crosses the x-axis. These are the solutions. We set the quadratic equal to 0. Isn't that how we solve quadratics? We always set quadratics equal to 0 to solve. So if they're asking me to find the x-intercepts, I simply set the quadratic equal to 0. I make the y 0, in other words. The y is 0. So I end up getting 0 equals ax squared plus bx plus c. And I can use factoring, I can use the quadratic formula and allow me to solve. Those are going to represent my x-intercepts. And then we need to be able to graph the quadratic. So I need to be able to identify the vertex from vertex form. I need to find the x-intercepts, which is simply setting the function equal to 0. And I need to be able to graph the quadratic, which again, a t-chart. Use your vertex, use your axis of symmetry. Those kind of things will allow you to help you graph a little bit easier. So let's look at some problems here. It says, how many x-intercepts does the function have? This goes for each of the examples here. I have 3 examples. So we take a look at the first one. Now I'm going to help you out on how many x-intercepts you have by one more key component that's not really in your section, but it's going to help you, and that is concavity. Now, concavity is the direction the parabola opens. Direction of opening of parabola. Now, the parabola is either going to open upwards, which is like this, or it's going to open downwards, which is like this. Now, how we can determine whether it's up or down, this is up, this would be down, okay, would simply by looking at the A. Now, remember what the A is. The A is the quadratic terms coefficient. If I look at the A and it's positive, greater than 0, then it's going to be concaved up. Now, how can I remember that? Well, when you're in a positive mood, what does your mouth usually look like? Okay, when you're in a positive mood, you usually smile. So if the A is positive, it's concaved up. Okay? If you're in a negative mood, so if A was negative, usually what happens is you're a little bit more looking like that, your face does. Okay? And so the A value will determine its concavity, the parabola's concavity, which will assist you in determining how many zeros you're going to get without even solving it. So let me give you an example. If I knew the vertex was here, let's say we found the vertex, and I know it's right there, and I know it's concaved up. If it's and the A is positive, in other words. The A is positive, it's concaved up. If it's concaved up, how many times does that cross the x-axis? None. There are no x-intercepts. Okay? Let's say instead of concaved up, the A was negative, which means it's concave down, which tells me how many times does it cross the x-axis? Twice. There's 2 x-intercepts. And then we can go about finding them. But the first question is, how many x-intercepts do you have? 0, 1, or 2? Well, that would be an example of the 0 and 2. Let's show you an example of a 1. Okay. And so, let me get a new graph that looks bad. Here we go. And so, if we had a graph, let's say, where the vertex is on the x-axis, now whether it's concaved up or whether it's concave down, if the vertex is on the x-axis, you're only going to get one x-intercept or one solution, one root, because that's the only time it touches the x-axis. Okay, and so that's a possibility as well. But concavity will help you determine that. If it's concaved, if the A is positive, it's concaved up, smiley face. And if the A is negative, think frown face, which is concave down. So the A value will help you determine its concavity. So we look at this one. What's our A value? The A is what's in front. It's a 1. What's in this one? A 1. What's on that one? A 1. So all three of these are concaved up. How do I know that? The A is positive. And if the A is positive, I'm concaved up. So all I need to do is find the vertex, and I should be able to at least know how many x-intercepts I have. Well, I need to be able to look at the vertex form and be able to find the vertex. Now pause it here and you try it. Okay, see if you can figure out what is the vertex right here. This is in vertex form. Again, vertex form looks like this. You get that down. The H is counterintuitive. The K is exactly what you see. So in this case, the H goes first. The K goes second. The H in this case would be what? Should be positive 4. Looks like it should be negative, but it's actually positive. The K is going to be exactly what you see, which is negative 2. So 4, negative 2 is our vertex. So just real quick, let's sketch that. 1, 2, 3, 4, negative 2. It's concaved up, right? So it's going to cross twice. I don't know exactly where yet, but I know it's going to cross twice. So we're like, well, how do I solve this thing? This is pretty easy. What do we set quadratics equal to solve? 0. Okay, so let's do this. To find the x-intercepts, you're going to plug in 0 for y, which is setting it equal to 0. And we're actually going to just simply solve this using the square root method. We know we're going to get 2 answers. So what do? We got to isolate. We got to get to the x, so we got to isolate the square by adding 2. And then simply use the square root method. Whatever you do to one side, you got to do the other. Oh, wait a minute. Do you remember? I'm personally responsible for the square root sign. And if you're personally responsible for it, you must have your plus or minus signs in front of that. And so you get x minus 4, and then simply add 4, and there you go. There are your 2 x-intercepts. What you're going to have is in order pair form, you're going to have 0, 4 plus the square root of 2. And then you're going to have 0, 4 minus the square root of 2 as your 2 order pairs. And they may ask you to put it in decimal form, just use a calculator to figure out what those 2 values are as decimals. Okay, but that would be the solution to the first one. Now I'm going to go ahead and delete everything here, so make sure to get this written down or rewind it to check it out again. Let's go ahead and take a look at the second example. Again, they're asking for the vertex. Now we said the A was positive, so it's going to be concaved up. This one's, let's say there was a negative in front. That means it's concave down. Okay, so if we had something like that, that's your A is negative, frown face, concave down. But all 3 of these are concaved up. So we go ahead and say, what's our vertex? Well, it's the opposite of what you see here. That's your H. And then it's exactly what you see here, 4, 3. What are your x-intercept? Set your quadratic equal to 0. You can see this is going to be the same things over and over. Now let's take a look at this. Now, if I plot, let's graph it real quick. 4, 3, there it is, and we said it's concaved up. Oh, we already know how many, there should be 0 x-intercepts. It's not going to cross it anywhere. So if it's asking for the x-intercept, I put none. I don't even need to solve it. Now, if I did solve it, look what's going to happen. I subtract 3. Uh-oh. You see what's going to happen? You square root both sides. Look what we just took the square root of, a negative. And with functions, we're talking about real values. So in this case, when we get positive or negative I squared to 3, we're talking about a complex or imaginary solution that's not going to be an x-intercept. In other words, it doesn't cross the x-intercept anywhere. We would have no x-intercepts for that type of problem. So we've had an example where we had 2. We had an example where we had none. Okay, let's take a look at the third one. Looking at the third one here, what's the vertex? Well, again, it's in vertex form. How do I know that? Here's the form. And I've memorized it, and hopefully you will too. H is counterintuitive. It's the opposite of what you see. And then K is exactly what you see. And so there's our vertex. So if I go 3, negative 16 is way down here somewhere. And then our A is positive, so I know I'm going to get 2 solutions here. So I just sort of sketch it just to make sure I'm getting real solutions. I'm going to get 2 of them. So what we want to do is set this quadratic equal to 0. So I set the bubble minus 3 squared, minus 16 equals 0. And you can see everything's going to work out fairly nicely on this one. Square root both sides. Don't forget your plus or minus signs. Square root of 16 is 4. And then I simply split this up. And I'm going to add 3 to 4. And I'm going to add 3 to negative 4. Okay, by splitting that up, I have two problems here. So I end up getting x is 7, and I get x is -1. And those would be my x-intercepts. And they want it probably as ordered pairs, so I put it as possibly 7, 0. And then the second one would be -1, 0. Okay, would be our x-intercepts. Okay. All right, very good. Now if I go back real quick, or excuse me, let's just move forward. Quadratic functions and their graphs. Find the vertex and the x-intercepts exactly for the function. Okay, so notice this one is not in vertex form. Now, you could put it in vertex form. Okay, there it is right there. Or you can cheat. Okay, and it says don't tell your folks. Okay, but we're going to cheat a little bit. And we already are familiar with the x value of the vertex. But here's the formula to find the y value of the vertex. 4ac minus b squared all over 4a. So again, if you can find your a, your b, and your c, and you can memorize these. It takes a little while to memorize them, but if you can get those down, man, it makes your life a lot easier. You don't have to put it in vertex form and complete the square and do all kinds of crazy stuff. What you can do is simply look at this and go, look, my a is -2, my b is -4, and my c is 16. So what I want to do is if I want to find my vertex, I can find the x value by simply doing the opposite of b. Well, if b is -4, what's the opposite of that? +4 all over 2 times a. So I end up getting 4 over -4, which is -1. There's my x value. Now you could take this and just simply plug it back in. So if you don't memorize the y value of the vertex, not a problem. You can take the -1, plug it back into your function, and you end up getting -2 plus 4 plus 16, which I believe ends up being 18 is what we end up having. So -1 squared is 1 times -2. -2. Then we have a +4 because -4 times -1. And then we end up getting 18. So this is our vertex. But let's go ahead and use the formula to find the y value. The y value is 4ac. So 4, -2, c is 16, minus b squared. And our b is -4 squared. So this is a little bit lengthier. All over 4 times a. Now, for this problem, you may be like, why wouldn't I just plug it in? That's a lot easier. That's true. However, on some of them, especially with fractions and things like that, it's probably a little easier sometimes just to find the y value this way. But we go ahead and we get -32 times 4, which is -128, I believe. And then we end up getting -16 all over -8. And so if you go ahead and you have a calculator handy, you can go ahead and evaluate this and see what answers you get. And so -128 minus 16, if we go ahead, I'm going to plug it in a calculator and just make sure I have the right ones. 128 and 16, we get -144, and then we get that over -8. So if you divide that by -8, what you end up getting is, guess what? 18. Imagine that. That's amazing. Okay? So it ends up working out very nicely. Okay? In order to find the x-intercepts, we must set the function equal to 0 and then factor. So if they said, hey, where are the x-intercepts? Because here it says find the vertex and the x-intercepts, I would simply set this function equal to 0. And so there's our function. Now, my suggestion is this. Notice that our a is negative. You don't have to do this, but I would encourage you to make the a positive, which all you have to do is just change the signs of everything. What you're doing is multiplying everything by a -1. But I think, especially with factoring, that makes your life a lot easier. Now, in this specific problem, you could actually divide everything by a -2. But if you wanted to change the signs first, it would look like this. Because 0, the opposite of 0 is still 0. Then if I divided everything by 2, that makes everything look real pretty for me. And then I can go my double bubble, and you get x plus 4x minus 2. And then you get your solutions are -4 and 2. And those are your x-intercepts. So how would we write it? -4, 0, and 2, 0 would be your x-intercept. So getting a little messy there for you, but hopefully you can follow along. To find your x-intercepts, remember we set the function equal to 0 or make our y equal to 0. Moving on here to the last couple examples. If you look, how many x-intercepts does the function have? Now these aren't in vertex form. So to find the vertex, we got a little bit of work, but notice our a here is positive. Looks like the a is going to be positive on this one as well. This one is not in really any form yet, so we'll have to do some manipulation there. But it's going to be concaved up. And this one's going to be concaved up as well. Let's find the vertex. Now, rather than put it in vertex form, let's go ahead and use the opposite of b over 2a to find the x value. So what's the b? 9. My a is 1.
My b is 9, and my c is 20. So what's the opposite of 9? Well, negative 9. What's 2 times a? Well, 2, because 2 times 1 is 2. So there's my x value of my vertex. Now, this is what I was getting at. Taking negative 9 halves and plugging it in will get you the right answer, but I don't know if that's necessarily the best way of doing it. You can do it that way, but another way is simply using our formula, which is finding the y. And if you go back and take a look, it's 4ac minus b squared over 4a. And so if we go ahead and go, okay, it's 4ac minus b squared over 4a. Then we go ahead and go, well, 4 times 1 times our c minus b squared, which is 9 squared, all over 4 times 1. And so you get 80 minus 81 all over 4, and wow, that wasn't too bad, negative 1/4. That was a lot better than plugging it in, to be honest with you. And so there's our vertex, negative 9 halves, negative 1/4. That would be my answer right there. Now the x-intercept. Now the x-intercept is where we set the function equal to 0. So, man, this one's going to be a lot easier because all I have to do is factor or use the quadratic formula. And on this one, it looks like I can factor to x plus 5, x plus 4. Multiplies to be 20, add to be 9. And you get your x-intercepts to be negative 5. And you get your x-intercept to be negative 4. And if you had to put it as an ordered pair, it would be negative 5, comma 0. And then negative 4, comma 0 for your x-intercepts. Taking a look here at case of x equals x minus 5 times x plus 3 plus 6. What's our vertex? Well, we got some work to do. I'm going to go ahead and erase all this stuff. So again, hopefully you have it down. If not, pause it and write it down. Then we get you caught back up. So we go ahead and we FOIL. And we get x squared. And we're going to get minus 5x plus 3x. I'm going to go a little quicker here. And so we end up getting that once we FOIL this. So you end up getting x squared minus 2x plus 1. So there's our quadratic right there, written a little bit more like this one up here. And so we can go ahead and find the vertex by, again, locating our a, which is 1, our b, which is negative 2, and our c, which is 1. And it goes the opposite of b, so it's going to be the opposite of negative 2, all over, so the opposite of b all over 2 times a. And so we go ahead and we get 2 over 2, and wow, that worked out really nicely. And so 1 is my x value. Now this one would be easy to plug in. You can plug 1 in, whether you plug it in here or here. 1 minus 2 is negative 1 plus 1 is 0. It looks like our vertex is 1, 0. That's interesting. Because when the y value is 0, wouldn't that be our x-intercept? So we just found the x-intercept as well. It's 1. It's 1, 0. Because anytime you find the x-intercept, the y value would be 0. If you set this equal to e0, let's say you didn't recognize it, and you're like, well, let's go ahead and set it equal to 0. Then when you factor this, you get the same answer twice. You get 1 twice. You set each bubble equal to 0, and you solve, and you get 1. So there you go. And so the 1, 0 is not only the vertex, it's also the x-intercept. Which means, graphically, you go to 1, 0, you have a dot. There's your vertex. And then it's concaved up. You'll get some graph that looks something like that if we had to graph it. So that is quadratics and linear functions. Really the vertex, x-intercepts, making sure you know how to graph using a t-chart, slope-intercept for those linear ones. Be very careful on if they're asking for ordered pairs, make sure to specify which one comes first. I think if I go back, for some reason sticking in my mind, you might want to rewind it. I think on one of these, the x-intercepts, I may have put the value second. The x values always should go first. The y values are always going to be 0 for your x-intercept. So if you wrote those down, you might go back and double check that. I don't want you to have the wrong thing in there. And for some reason it's sticking out of my mind that I may have done that. So go back and double check that. But otherwise, if you have any questions, make sure to bring those to class with you, and I'll be able to answer those when you get there.